this working? Okay, good. So is the food coma settled in yet, or is everyone waking up a little bit? Hopefully a good session. This is both good and bad. This is also quite a full talk, so we're going to be covering a lot of things. Basically, the talk is securing, connecting, and scaling in Windows Azure, and we'll largely be talking to these points by highlighting capabilities of the Windows Azure platform. So when James was speaking, he talked to you about compute, storage, and we talked about database, and what I'm going to talk now about are some higher level services, platform services that are available to you as developers to start taking advantage of within your applications, to do things like making them secure, to be able to connect to your applications, be they in the cloud or on premises, and then also services that you can take advantage of in order to scale your application better. And so one thing to point out is, we've had a bunch of material, some of it introductory, some of it more advanced, but we've covered a lot of basics. Certainly there's more to it than just what we've been able to cover today, but this talk kind of goes beyond those basics, so I'm not going to be reintroducing or explaining web and worker roles, SQL Azure, storage, and so forth. And we're going to move a little bit beyond and focus on these higher level services and what sort of capabilities they provide. And so these are the three areas: securing, connecting, and scaling. And to start it off, we're going to talk about securing your application. And we're going to do so under the context of a service provided by the platform called the Access Control Service. And essentially what this is it's a service that makes it easier for you to authenticate and authorize users into your applications. We released the Access Control Service back in 2008 when the platform first came around. At the time, we called it the V1 service, and it provided very simple semantics and capabilities for securing web services. That was really it. It was token exchange, parsing tokens, and so forth. More recently, we released an update in a new version of the Access Control Service we call it ACS v2, which provides more capabilities for securing applications using additional identity providers. And so you can start building some single sign-on experiences that really can make your applications more appealing to your users. And we do it by leveraging standards defined by various organizations and identity providers that allow us to make it easier to tap into these identities. So one of the things that you can leverage within the Access Control Service is Active Directory. So you can have your Active Directory and use ADFS or some way of basically talking DevS Federation, and you can start leveraging those identities via the Access Control Service in your applications deployed up into Windows Azure. Similarly, other web identity providers like LiveID, Yahoo, Google, Facebook, and even OpenID or ACS through OAuth and Twitter through OAuth and so forth. These other identity providers can also be plugged into ACS so that you can use them within your applications. And so the idea is, rather than being focused on building an identity store for your app, like how many of you have ever used SQL Server for a membership provider for an application? Or how many of you have tried Windows Azure Storage to provide membership repository for your users? Building all of these things for our apps takes time. It exposes us to certain challenges. It means that we're now responsible for managing other people's secure credentials. And by leveraging these other identity providers, it lets us kind of get out of that identity business. And so what I want to do is just, I figured before I start walking through kind of the workflow and how this all works, I give a couple of very quick demos here. And I just want to highlight some of this stuff because I don't want you to think that it's magic. It's actually fairly tangible things that you can leverage within the application and get things to work. So here I'm in the Windows Azure portal. We have a section here called Service Bus Access Control and Caching. And oops, I clicked the wrong one. And what I'm going to do is select this, and you'll see here now I'm basically in the @Fabric section, and I can select the access control, and I will see my service namespaces for the @Fabric. You can think of this service namespace as really being like a logical partition of the service that is yours to use. Because these services, access control, service bus, caching, are multi-tenant services we provide to you to leverage. And so when you use them, you essentially register, and you have your own, if you will, slice of it available to you. Oh, come on. Well, okay, while that's, I have no idea why it's not loading. What I'm going to do is show you the end user experience. So we've got a tool we just released actually recently called BlobShare. And I'm going to show you what the finished end result looks like. So I'm going to browse up to this BlobShare website, and it says, hey, let's share some data. So I'm going to go ahead and sign in. And what you're going to see here on the right is a list of identity providers. And essentially, this is a home realm discovery experience where I get to choose as a user which identity provider I want to use to log into the website. So the application isn't explicitly bound to one identity provider, nor did I write the application with its own individual membership store. I can use existing identity providers for it. So I could use LiveID, Yahoo, Google, Facebook, or Microsoft. And it's actually, I'm going to show you this as a very nice SSO experience because I'm actually on the Microsoft Corp network. So when I select Microsoft, I don't even have to put in my credentials. It's just going to use my identity that I'm logged into. I'm able to coordinate with Microsoft's Active Directory, and I was able to log directly in. And you can see it knows who I am. So that's kind of that nice experience. Did I see a hand real quick? Yeah. So the question was, do you have to use the same identity provider each time you come back? It depends on, like if I'm an end user and I want to get access to my account, yes, I would use the same identity provider. So if, like for instance, right now, my Microsoft account that I logged into this application, it's tied that ID through Microsoft Active Directory to everything else within the website. Now, to be honest, that's a function of how the web application was written. It's tying it to an identity that was used through the access control service. I mean, if you wanted to allow people to use multiple IDs to log in and have access to the same things, it's possible. That's more of an implementation detail of the application. So all access control service does is it facilitates the ability to log in through multiple identity providers, and then to the application just gives one consistent set of claims. I didn't want to get to claims yet, but it's basically just it's doing all the transformation of the underlying protocols used by the different identity providers and bringing it back to one experience for my app so that my app doesn't have to be programmed against each individual identity provider. So again, like I think the question you're asking is more of a, how would you want to implement the app? You could. So, okay. So at any rate, so that would be the end user experience. Now in the portal, let me go ahead and see if I can get this to load up now. What I want to do is show you how you go about configuring which identity providers you would use, how you would set up the mappings, and how you would define some of the rules. So here I'm going to go ahead and I'm just going to select this WA camps and click this access control service. Some people have wondered why we seem to go to a different portal for the access control service, and the reason actually is the access control service itself, you can access it using different and multiple identity providers. So it actually has a somewhat of a different login mechanism itself than the actual underlying portal does, which is why you kind of get bounced around a little bit. But now you can see up here, we've got a couple of things. We've got identity providers, we've got relaying party applications and rules. So let me show you what we would do. So by default, Windows Live ID is added, and it's always going to be added. I can also add additional identity providers. I can add Google, I can add Yahoo, and in fact, these two options are actually quite quick and easy to set up because it doesn't require any additional input from me when I set it up. So I can go ahead and say Google, go ahead and add that, and I can change the name or I can save it, and I can start adding additional ones. For instance, if I wanted to add Facebook, one of the reasons I'm not going to do this whole thing, but it wants to know your Facebook application ID, your Facebook secret, and so forth. So it's not that much more information, but it's just a couple of additional steps, pieces of information that you would add. So I'm going to go ahead and add Yahoo as well. And so at this point, I've added 3 identity providers. So essentially what I've done is I've configured these 3, and eventually when my application will use these would be served up as identity providers that someone could use to log in. Now, the access control service needs to know something about your application. So for instance, I've had to configure BlobShare, access control service to know about BlobShare so that when BlobShare tries to grab a list of identity providers or wants to interact in some sort of authentication or authorization, the access control service knows something about that party. So we call this a relying party because this party is relying on ACS. And essentially, I can go ahead and just add some information. I could say BlobShare. And if I had a WebS Federation metadata file, I could load it. I can also enter this stuff manually, so I can end up putting information like blob share into it. And then I can set some things. I can choose token formats based on what my application would need or want, and so forth. So hopefully you get the idea. Now at the bottom here, what I'm going to do is also authorize or basically define which identity providers can be leveraged along with this relying party. So, for instance, I could optionally choose to turn Windows Live ID off or leave it on. And I'm going to go ahead and save it and let it create a new rule group as well. So we'll save this. And so now I've got blob share. And now I go and define the rule groups. And the rule groups really are what we're responsible for transforming the claims that come back from the individual identity providers and then map it to the claims that my application uses. So I'm going to go into this group, and I could go through and add each of these claims. So I could say, for instance, identity provider Google, for the input claim type of name, I'm going to and any value, so any value that comes back from the Google claim value of name, I'm going to transform it into an output claim type of, and I could then choose, name, and then just pass through the value that came through and save that. So I could map this. So essentially what we're doing is we're saying Google has a set of claims that comes back after the user logs in, and then on the flip side, my application expects these claims to come in. So go ahead and create that mapping. Or what we can also do is just generate. And what generate will do is generate the most common claims mappings for us so that we don't have to go through and individually do it. We can still tweak them, we can still change them, we can make modifications, but this will set up all the mappings for us. At this point, the access control service bit has been configured. There's really not a lot left that needs to be done. At this point, it can take a claim that comes in from one of the identity providers that we've specified, transform it into then a claim that our application uses and understands. For our application to interact with it, all we really need to do then is grab this federation metadata file, which we can then use to tell our application how to parse and use these claims that come back from the service. So pretty neat. So one last thing that I wanted to try to show you here is the single sign-on experience was nice, but I wanted to show you what happens when you choose a different identity provider as well. So this time I can choose Live ID. And since Live ID, I'm going to have to log into it, we'll show you what the experience is. So I'm going to click Live ID, and I will get redirected to Live ID's page where I can log in. So now I can log in with my identity. And then if you can see, it's going to be really fast. Up here, you see how we're back, now we're on access control service, and now we're back to my website. It's a form of passive federation where through redirection we're able to pass the tokens back and forth so that ultimately the tokens that I need for the application end up back at my app. So that's basically it from an end user perspective. Now let me give you kind of a little bit more of an idea as what's going on behind the scenes to make this possible. So there's 4 parties here. We've got the client, which is me, the user, an identity provider. This could be Live ID, ADFS, Facebook, et cetera. We've got the access control service itself, and then the application. So this is the application like blob shares. And so the client is first going to go to the app and request access to a resource. This could be the login experience to a page. Maybe the entire website itself is secured. But they're going to ask access for that resource. The app is then going to redirect them to the identity provider that they selected. So imagine this is Live ID. So we'll get redirected. So a redirect is sent back as a response to the client's browser. The browser then will take that information and then redirect you onto the identity provider's login page. So you saw I landed on Live ID. So then I log in. When I log in, what it's going to do is issue a token that's then sent back to the browser, and then I will then send that token onto the access control service. So the access control service now has a token from the identity provider. This is not the token that my application understands, and that's important because access control service is transforming these tokens into something my app is used, something that's consistent. I don't have to program my application against all the protocols and all the specific settings of the identity provider's token. The access control service does it for me. So now the access control service has the token. It'll validate it. It'll run some rules on it. And then it'll issue the token that my app understands. That token then gets redirected back to the client. And then essentially what that client then can do is take the token from ACS and send it off to the application. So now at this point, BlobShare, or whatever the app is, has the token that it understands and trusts from the access control service. It can validate it, because you still want to make sure that the token that was given to you is a valid access control service token, and then it can return the resource back to the user. Seems like a lot of steps, and there are a lot of steps, but the experience, as you saw, is really quite straightforward and relatively fast. These redirects happen, for the most part, in such a way that the end user, is really not exposed to it whatsoever. But this type of you can think about this as decoupling the underlying identity protocol provided by the identity provider from the app, and instead we're using the access control service. So real quick, one of the things that makes using the access control service, especially in the world of .NET and Visual Studio and so forth, really useful is the Windows Identity Foundation. And this is essentially a framework. It has a set of runtime libraries that you can program with. It has an SDK with tooling and so forth, and makes it really easy for you to consume these tokens, parse these tokens, and essentially make your applications claims aware. Because realize the token that you get back has the underlying claims that you can then use to drive the experience for the user that logs in. Like I said, the access control service via the token provides this framework of claims that you can use within your application. There's actually quite a few protocols that are supported here. OAuth Wrap, WS Trust, WS Federation. This is essentially how the access control service can work with so many different identity providers. Live ID, Google, Facebook, ADFS, and so forth. The fact that it supports these protocols. And it supports a number of these token formats as well. So your application can be driven off of a simple web token, SAML tokens, etc. So it's a very flexible system. The Home Realm Discovery page, which is essentially what you saw for the login experience, is really quite easy to use. You can use a default hosted Home Realm Discovery page from the access control service. So you basically see a bunch of box, and the URL will be at the access control service URL. Or you can query it and get back a feed of data. I believe it's a JSON feed. Is it a JSON feed? I think so. But essentially, you'll get back the data from the access control service that you can then use and render within your own application. So that's how you saw that BlobShare had a really nice integrated login experience, at least Home Realm Discovery page with all the identity providers listed out. And one other thing, and this is really nice, and I think you're going to see the net effect of this in Nick Harris's talk next, is everything we did in the portal is available through a management OData feed, which means that you can script out and automate that entire process so that you don't have to go to the portal in order to configure this. And our team has spent a lot of time on tooling for certain resources to try to make that process as simple as possible. It also means that tools like the PowerShell commandlets within the Windows Azure platform, you can use those to even set up and script out the access control service. So that's it. So that's the securing section, the access control service. Really, really great service. It's also quite, I'm trying to think of, it's very scalable. We've used it on some very large websites, and something that I think it's one of the higher level services I see people most excited about. Now we're going to pivot over to connecting. So, and when we're talking about connecting here, essentially what I mean is we've got resources and applications and services running up in Windows Azure, and most of us also have these have resources and applications and so forth running locally, be it on our desktop or our data center and so forth. And the analogy that I really like to hear is we can't always just forklift an application and dump it off into the cloud. And sometimes we have to take a more hybrid approach or a slower approach where maybe data gets moved or maybe services get moved. And so having some capabilities around connecting these different assets within the cloud and on premises becomes quite helpful. And so the two services we're going to be talking about are the service bus, which if you've been introduced to the service bus over a year ago, and you hadn't really looked into it since, you'll be surprised to find that there's been quite a few things added to it. So we'll talk about the service bus. And then also we're going to talk about another service called Windows Azure Connect, which is, and some people get confused as to when to use the other. And I'm going to try to provide some framework for understanding how and when you can and should. So the service bus's mission ultimately is to provide secure messaging and connectivity between applications that exist in different places. It's really much there for building these hybrid apps. And it does this by providing a lot of different communication protocols whereby you can start loosely exchanging messages. It'll do this all through various standards, protocols, and so forth. There's two pivots to it. And so what I meant when I said if you hadn't looked into Service Bus in over a year, you're probably only familiar with Service Bus connectivity. What we've introduced more recently as a CTP earlier this year, and then we just recently went RTW on it, is Service Bus messaging. And so let's drill into those a little bit. Service Bus connectivity is really about finding a way to get across different network topologies by relaying through a set of sockets running in Windows Azure. And wow, that sounds like a lot of stuff. Basically, what we want to do is provide great relay mechanisms where we can establish connections between different parties that live in different networks. So consider that you've got a service or an application running on premises. You've got a service and an application running up in Windows Azure. Those two, unless you open up across like an open port, use port 80 or something like that, they're going to have a hard time rendezvousing and connecting because there's going to be firewall restrictions in place. There's going to be things will be blocked on inbound ports. Things will be blocked on outbound ports, and it can be difficult unless you attach to various semantics around HTTP and so forth. It'll be difficult to establish a rendezvous between the two. And so the service bus acts as a relay that makes this more capable. And so basically allows you to traverse firewalls so that you can get around the fact that certain ports are blocked and establish direct connections between different parties. It occurs to me that at that point it would be really nice to walk through this here because I think this helps to illustrate what I'm talking about. So up at the top, we've got the service bus running up in Windows Azure. And we've got two different parties. We've got party on the left, which is the sender, and party on the right, which is the receiver. And essentially, what we want to do is establish a connection between the two of them where we have an open socket connection that we can just send information down. And so typically, you'd typically imagine a straight line being drawn across the two, right? If they were in the same data center, same network, you just open up a socket connection and you just start sending data. But when they're living in different places, this becomes more difficult. And so the service bus helps with this rendezvous mechanism. So what we would see here is before we ever start to try to send information, the different parties are responsible for connecting up to the service bus. And so what the receiver here is doing is it's establishing an outbound socket connection to the service bus. And I say outbound because, a bidirectional outbound socket connection. And it's bidirectional because what we're doing is we're going to create a long-lived persistent connection from the receiver to the service bus, and we're going to keep it open. And since it's bidirectional, that means that we can send data back down that socket connection to the receiver. So now you've got a socket that from the service bus, you can start pushing data down to a receiver that's listening at the other end. Meanwhile, the sender is going to send a message or establish a connection to the service bus at a known port. And what we can do now is once that's created, you can send a message through that connection. The service bus knows how to relay and basically take that message and send it to the outbound connection so that it can then, so that it can then send that message down the open outbound socket connection to the receiver. So you can see here, and this is done at the socket level. So this is a TCP socket that gets opened bidirectional, so you can start pushing down communications through this connection. For example, I've shown demos. I don't have it ready to show today, but essentially running SQL Server or MySQL on my laptop and then having a web application running in Windows Azure that through the service bus was able to directly talk to that database without having to go through services or anything. So it provides a great way. You can think of this as a way of creating like a very fine connection between two different parties in order to send some information. Okay, so let me just jump back here now and talk about some of these capabilities. What's that? Oh, I'm going to get to it. Yeah, so there is also so the service bus is integrated into the access control service as well. So when you establish that connection to the service bus, you have to present a valid token that's been acquired from the access control service. So, and you usually use like a service identity rather. There's one access control service before I talked to you guys about like the login experience with the social and those identity providers, there's also a kind of a service identity capability as well that's meant for things like Service Bus. So with connectivity, basically there's a lot. I showed you one pattern, but there's a lot of different patterns enabled through this relay mechanism. So you can do one-way unicast, you can do one-way multicast. So rather than just having one receiver, you could have 100 receivers all listening at the same endpoint, and then one sender can send a message that's relayed through to all the receivers. You can establish direct socket connections and then have full duplexing across it so that you can have bidirectional communications. And then, as I just mentioned before, the endpoints that you're connecting to are secured by the access control service. So you always have to present a valid token in order to connect and start listening or sending. And the connectivity options, I list those. You can always look these up, but essentially there are a few ports that the service bus needs in order to optimize the experience. So imagine having to do everything over HTTP, which is a good default backup protocol. It's a little bit slower. We first try to use some certain outbound TCP ports. If those are not available, if those are blocked, then we'll try to use HTTP. If everything is blocked, well, it's not magic. If every port inbound and outbound is blocked, there's very little we can do. For the service bus, it's important to understand that the service bus talks NetTCP, which means that there is an implicit use of WCF and .NET as part of the relay mechanism. So in terms of using the capabilities that I talked about through Service Bus with connectivity, it does mean that you're writing .NET applications using WCF. And it's the WCF relay bindings that make all these capabilities possible. And again, remember that the protocol format is NetTCP. And so we have special bindings in WCF that make this pretty, relatively simple in order to use the different types of relay mechanisms. And then you can even customize these things as well. It's worth noting that there is a web HTTP relay binding that lets you have REST clients also interact with this. So, for instance, there are capabilities and opportunities for HTTP-based apps to also send and/or receive messages through the service bus. And we already went through this. All right. So that was service bus connectivity. Now, pivoting over to messaging, connectivity provides some really great opportunities, I think, for establishing these direct connections and sending information. Messaging provides somewhat, it's trying to solve the same problem, but in a different way. And so messaging provides a reliable, durable, and transaction-aware message queue. And so rather than establishing these direct connections directly to each other, it's doing it in a decoupled fashion by using a queue in between. And one of the things that is nice about this is it also makes it fully addressable over HTTP. So we're no longer bound to just NetTCP in order to start doing some messaging between different parties. And there's probably some of you that say, well, this sounds a lot like just queues in Windows Azure. And you're right, in Windows Azure Storage, and you're right. It is similar in principle to Windows Azure Queues. However, since here we're trying to solve messaging problems, there's additional semantics that are available to Windows Azure to Service Bus queues that allow for different types of things like pub sub, different types of things that make message relay possible. So let me talk about some of those. So here's an example of basically using a service bus queue in order to, in two scenarios here mentioned. Load leveling, so this is a way of essentially making sure that you can decouple load from one party to another. It's very much the same as what I talked about in the storage talk about being able to have things scale independently. And in that way, your sender on the one side, since it's essentially depositing a work item or depositing some stuff into this queue, is most likely not going to get overloaded. You can focus those resources on the other side, on the receiver side. Also, this also gives you the opportunity to start working in offline modes. Especially like thinking about mobile scenarios. Your receiver that you want to send a message to may not always be online. In the connectivity world, which I just talked about, both parties always have to be online in order to establish a rendezvous so that you can send data between them. In this world with messaging, you can place something in a queue, and then a party can later on, when they come online, grab that message out of the queue. So it allows for an offline opportunity. we also can do load balancing. So rather than having certain resources on the one side getting overwhelmed, you can actually use it as a mechanism for providing some load balancing opportunities where you've got different parties that one of them grabs the work item and does the processing, another one grabs a different work item, and so forth, and so that the work is being distributed across multiple receivers. Again, it's done through this simple queue. And then we have some more advanced capabilities through subscriptions that allow for some pub sub capabilities, and we call this topics. And essentially, what happens is you've got receivers on the one hand that are subscribed to a certain topic. So think of it. I don't know if you guys, anyone here has done BizTalk, but you have a message context, and you could have a party that was looking for a message of a particular message context. Similar in concept, I've got receivers that are looking for a message that are going to be placed into a queue with a particular topic. And so when an item is written into the queue, you can attach a topic to it, and then any party that's subscribed to that topic can receive that message. So that gives us the ability to have a publish-subscribe model. It also allows us to, it allows for this type of pub sub. Now, I'm still not convinced that this is the best slide for it, but I did want to at least try to show how these things kind of fit together in a world where you've got apps on the one hand and then the service bus. And if you take a look, the way we're trying to position this here is that, in some cases, WCF, the service model, NetTCP, net messaging binding, all that stuff that provides the direct connectivity capabilities is great and provides an answer. And so you can leverage the service bus to integrate and connect your applications. In some cases, however, you want to speak different wire formats. You just want to talk HTTP protocol, those sorts of things. And you can still do that through that messaging API. So it's kind of a, here's one option if this works. Here's another option if this works. Together, both of them provide some pretty rich capabilities at the application tier for connecting applications. Certainly. How many subscribers can subscribe to a topic? I don't know, but I bet you Bing could tell me. I don't remember. Sorry. Yeah, I'm sure there's a limit somewhere. I don't remember what that limit is. Oh yeah, so service bus connectivity, certainly, and again, so service bus connectivity, there is a number, and it's because of the way in which we internally run the service bus. We have this concept of a scale unit, and a lot of those numbers are governed by how much we can scale out our scale unit. So similarly with topics and so forth as well. I don't remember the numbers. I'm sorry. Okay, so the question is, if I'm subscribed to a topic, does that count as a service bus connection? The service bus connection model, the pricing model, is extremely complex. I'm not going to try. Apologies. I'm not going to try to explain the connectivity model today. We are also changing that model. So, like if the service bus messaging today has no cost. That's one of the reasons is because we're working through the new model for cost and so forth. So that all has an impact on connections, and whether or not connections are the same in the future is TBD. But understand? Yeah. It's not going to be the same as it was in connectivity for messaging. I mean, that much is clear. Yeah. Hopefully those answers should be coming soon. But for now, we're still figuring that model out. So all these things are released. It's just the model around like how we track costs and so forth hasn't yet been determined. So it's free. All right, so now we're pivoting to Windows Azure Connect. Windows Azure Connect also aims at helping you connect your applications across different network topologies, where some of your apps are running on premises and some of them are in the cloud. However, whereas Service Bus is really targeting the application tier and the application level, what Connect does is it's handling everything at the network protocol level. In a nutshell, what it's doing is via IPsec, it's establishing an IPsec connection to the cloud from your on-premises environment so that your assets running in Windows Azure appear to be on the same network as your on-premises applications. And so you do this on a one-to-one basis. Right now, I think I'm going to talk through, I can actually show you as well. you're essentially going to, on your machine, like in your data center or at your desktop and so forth, you'll run a service that's responsible for communicating with a Windows Azure Connect relay service that's responsible for, at a networking layer, adding the resources in the cloud, such, basically handling that networking tier so that at a networking layer you can communicate. So basically, the whole stack is open to the application. Everything from being able to resolve to ping to do TCP type connectivity to the machine. So you're not having to do it at a particular port or the socket level. It's essentially opening the entire networking stack up between you and the assets running in Windows Azure. So you can see here in this picture, you've got like a laptop that'll have this service agent running on it, and it's connected to resources up in Windows Azure, just as some other servers are as well. Let's see. So in order to do this, when you build out your applications running in Windows Azure, you'll actually update your service model. So that's the CSDEF and CSCFG file that James showed you earlier. And you will update it so that it knows something about how you want it to interact with Windows Azure Connect. And I'll show you this in a moment. And you add that so that when you deploy it, that instruction is part of your package and part of your configuration information that's handed off to Windows Azure. And so when the Fabric controller starts everything up and starts to run your app, it can also take care of all the networking needs for Windows Azure Connect so that you can connect to it from your machine and from the local environment. At the same time, locally, you'll install this agent and you'll essentially connect to Windows Azure Connect, which will give you the ability to then access the resources running in Windows Azure. Whew. Let me show you what I mean here before we go any further. All right, so if I create a new application, Windows Azure project, I'm just going to choose a app. Just choose that. What I'm going to do is let me open up my service model. I'll show you right where I'll add it. So there's a virtual network tab here. And you'll see Activate Windows Azure Connect. So by checking this, what it's going to ask for me first is, put an activation token in. The activation token you'll get from the Windows Azure portal. So let me select this. Go ahead and sign in. And then from the portal, we'll configure the other side of the equation. And we'll get that activation token. So you'll see down here, we also have a virtual network location in the portal. And then we've got Connect here. So we'll load this up. All right. So basically, what I'm going to do is say Get Activation Token. And here I'm going to go ahead and copy this to my clipboard. And essentially, think about it this way. By getting that token and pasting it in here, now when, I'll save this. If we take a look now at the holy moly. That was not part of the demo. Yeah. Now this machine is actually needing a little bit of servicing. What am I doing? Let's open this back up. All right, so I think it's saved. So let me just check. Yeah, it did. Good. So let's take a look at the CSDEF real quick. You'll see that we've added a new module, so Connect. A module, basically, it's going to be adding a whole bunch of things that tells when the app starts up, it's going to install some things into the instance. It's going to configure some things and so forth. And it's going to look at configuration settings that I have here over in my CFCFG. So you can see here is a bunch of stuff actually for Windows Azure Connect, and here's the activation token. So, and you can specify other settings as well. But essentially, by having this packaged into my service model, when I go to deploy my app and it gets started up, well, now the Fabric controller can read the service model and it'll know that I'm adding this application to Windows Azure Connect. And so from the rest of the experience now, I can also drive from the portal. So you can see here there's an install local endpoint. Essentially what that's going to do is let me go out to a resource. Here, I'll just do it. I'm not going to install it, though. I just will show you. And it's going to prompt me to install this executable, and that executable has in it the service that will run on the machine. And when it's installed, it'll sit in the system tray, and I'll be able to use it to attach to a Windows Azure Connect group. So that's what will let my machine connect up to Windows Azure Connect. And then I can control all of this up here in the portal. I can define groups. I can take a look at activated endpoints. I actually don't have anything deployed right now. If I had deployed my CSPKG file and started it all up, I would end up seeing an endpoint here up in Windows Azure. And if I had the tool installed in the sys tray running locally, I'd see another endpoint. And then you can connect those endpoints. And Windows Azure Connect then is responsible for handling everything such that I can access these resources if I'm on the same network. So that's Windows Azure Connect. It's providing the same type of solution as Service Bus in that it's allowing me to connect different resources, but we're doing it at the networking layer, which means I'm not handling everything from the application at the application layer. Whereas Service Bus, I am actually handling things at the application layer in order to handle communications. I think I went through most of these details. Yep, so the policy is essentially what you configure up in the portal. And once you've got the agent running locally, and I've deployed my CSPKG file with that information, then through the portal I can manage that policy. And I kind of showed most of these things, how we update the CSDEF and so forth. And then on premises, you install and activate the agent. You connect it basically to Connect, and then everything gets managed for you. So that's Windows Azure Connect. So those are two capabilities that you can leverage for your applications for connecting things that are on premises to the cloud. So now we're going to pivot for the last 18 minutes and talk about scaling. And there's three services that I want to talk to. One is caching, CDN, which we've already gone through CDN, so I will breeze through that. And then Traffic Manager. James talked about the cache, but I'm going to go into a little bit more detail. It is a distributed in-memory cache. It's actually, it runs in Windows Azure. We manage it. We provision caches for you. We make sure that they are scaled across the right number of instances so that they are fast, give you really quick response times. It's extremely simple to administer. I don't know how many of you have set up Windows Server App Fabric caching and had to configure Windows Server and get everything going. Great application. It solves a lot of needs on premises, but it takes a while to configure and deploy. Windows Azure App Fabric caching literally takes 30 seconds to provision a cache that you can use. And you don't have to configure it, you don't have to manage it, and so forth. That's all done. That's the value of things as a service. It is really quite scalable, and some of the numbers, in terms of response rates, you're talking 2-3 millisecond response times from the cache. And as I think I alluded to, maybe I didn't, it's actually based on top of Velocity, which was the code name for Windows Server App Fabric caching. So it's based on the same technology. It's provided as a service for you, which is nice because it actually means that if you're familiar with Windows Server App Fabric caching, Windows Azure App Fabric caching will be pretty easy for you to take a look at. So real quick, just kind of this latency pyramid. A friend of mine, Karan Deep Anand, first kind of introduced me to this concept, and I think it's a nice way to look at really the value of caching, because you think about I/O, and I/O is really one of the things that we get bound to more than anything else in terms of adding latency to our applications. And at the bottom of the stack is disk. Disk is really pretty, it's pretty slow. And anytime you have to do disk I/O, it can take quite a while. There's a lot of ways to optimize around that, but it is something that increases I/O. Network is kind of at the second, because if you think about even a distributed in-memory cache, you're still accessing it over the network. So that means that you're introducing some network latency as well. And then at the very top, you'll have just storing things in memory. So you can think about, if you're familiar with like ASP.NET session state management and the default is in proc, well, that's just using memory right off the machine. It's extremely fast. You don't have to serialize it, deserialize it. It's not stored anywhere on disk. You're not going across the network. It's very fast. So trying to kind of look at these things in terms of latency perspective, and then saying, storage, Windows Azure Storage, SQL Azure, all these things at some point, because they're durable, they do write to disk. And so that does mean that it incurs some latency there. Windows Azure App Fabric caching as a distributed cache is a service, which means that even though it's in memory, there is network latency because you're communicating it across the network. However, there's an aspect of Windows Azure App Fabric caching called the local cache, where once you grab something from the cache, you can also put it in memory local on the machine, so that the next time you go to try to grab that information out of the cache, you can check the local cache first to see if it's there. That way you don't have to incur the network latency. So this is just kind of a way to take a look at it and kind of understand where Windows Azure App Fabric caching fits in. And what I'm going to do is show a quick demo of this. And this will actually be relatively quick because I'm going to use NuGet. NuGet's one of my favorite things, and it really makes some of these things easy. Oh, actually, let me start from the portal. So if I come here to the management portal and come to cache, I'll show you what I have here. So I've actually created, I have a number of caches. I used to have a lot more. At one point, I think I was the largest customer. So I've got a cache called WA camps, and essentially you can take a look at some data, some information about it. It's a 128 megabyte cache. It's distributed. It's going to be in memory. I authenticate it to it using the access control service. It's an addressable endpoint. So one thing that's also worth noting about Windows Azure App Fabric caching is that it also uses NetTCP because it's actually a WCF service that you're connecting to, which means that the interop story isn't as good as it could be today. But it's worth noting that you address this over the web. There's a URI to it, and it talks NetTCP to these ports. You can talk for HTTPS, or excuse me, for the non-secured, we talk at port 22233. And if you want to use SSL as part of this as well, you can talk to port 22243. So the management portal lets me provision, so I can come here and create a new cache. It takes 30 to 60 seconds. You can change the size. So this is kind of nice. We give you some data that says how much data is in your cache, how much was it at its peak, and so forth. And you can use that to make decisions as to whether or not you need to scale your cache up. So I want to go from 128 megabytes of cache to 256. Or if I'm at 256 and I really don't need that, I can scale back down to 128. And we provide some information here that you can copy and paste to make the application development experience a little bit easier. So all this is up in the portal. It's really, really quite straightforward. What I'm going to show is I'm going to create just an ASP.NET web app. And yep, that's fine. I'm going to show just what the development experience looks like. And I really I created this NuGet package a long time ago. It makes it really easy because to use Windows Azure App Fabric caching, you install an assembly. So there's actually a couple of assemblies that you'll install. And then you also update your web config file if you're building a web app, or if you're using caching in like a console app or something like that, you'd update the app.config. And that's where you'll put some specific settings, like where you'll specify what your cache URI is and so forth. So I'm going to go ahead and install this. And so this actually installs the assemblies I need, and it will also put some scaffolding in place in my web config so that it makes updating it really easy. So you can see here there's a section here called Data Cache Clients. And let me make this a little bit bigger. And you'll see that basically we have two data cache clients. We have a default, which is non-secured, and then we have the secured endpoint as well. And programmatically, you can use either one of these. It's just it's an aspect of how you instantiate the data cache factory. And so what I'm going to do is grab some information from the portal. So I'm going to grab my name, update this, and then I said it uses the access control service, and it does. And basically, we've got an encoded token that you'll use and put in config. So I think I copied that. So there's my token. All right. So basically, that's just providing information that the framework that I'm using locally will use to know how to connect to the caching service. And now, if I just come in here, I'm just going to do something very simple. You first create a data cache factory. And this is part of the Microsoft Application Server caching assembly, which the NuGet package added for us. And so I'm going to create this, create a new instance of it, and then I'm going to also create a data cache. It's really cold up here. My fingers are cold. It's hard to type. and I'm going to get the default cache. Now, as you dig into this, you're going to notice that there's certain things that you don't use for Windows Azure App Fabric caching, and that's because the APIs are consistent between Windows Server App Fabric caching and Windows Azure App Fabric caching. And there's a couple of things that you can do on the server side that haven't yet made it up into the service. So there's some things that when you're programming, you just don't use right now today for Windows Azure App Fabric caching. Just an FYI. And so what I'm going to do is I'm going to just do a real quick check. I'm going to do a very simple like cache aside pattern to see if something's in the cache. I'm going to say, if I'm going to say get, I don't know, data, if it's not null, go ahead and, if it is null, I'm going to say add data Wade, something like that. So basically, if there's nothing in the cache with this value of, for this type data, go ahead and add something into the cache with the value of Wade. This could be a spot where typically, this is where you'd call off to SQL Azure, call off to Windows Azure, and get that data, and then put it into the cache. And then down here, what I'll do is, I assume now that it's in the cache, I'll go ahead and say, data equals data cache get data as string. And then, I don't know, we'll just write it out. Something like that. And so let me go ahead and put a breakpoint here, and we'll go ahead and run it. Now note, I am running this locally. You don't have to run, you can actually address and use the cache locally. Just realize I'm incurring a lot of network latency, and there's really not a whole lot of value other than just showing a simple demo. Really, you want to make sure that you create a cache in the data center and have your application deployed to the same data center so you reduce network latency when using the cache. So basically, we're going to get that default cache. And now we're going to check to see if that value exists in the cache. Oh, shoot. You know what? I think I used that same value earlier. Let me change this real quick. Get data 5. I didn't use that. Let's try that again. All right, so it checked, and the value is null, meaning that the item didn't exist in the cache. So we're going to go ahead and add it. And now we're going to come back. We're going to grab it so you can see the value here is specified as Wade. And we'll go ahead and write that out. So here's Wade. Great. Now if I refresh, it's going to come back in, check to see if that's there. It is. We're going to grab it and write it again. So we didn't have to add it. So it's a very simple demonstration, but imagine that instead of just adding a static value, the hard coded into the app, it was calling out to a database. Or maybe it was calling out to some services, grabbing data, aggregating it before using it. So by checking to see if it exists in the cache first, you can really reduce latency and make these applications more scalable. So caching is something that in the apps that I build now I use invariably. And it's just one of those services that you can really look to use. So, all right. A couple of additional things. So we do have providers that we write and manage for session state and page output caching. This is really nice because for a long time it's been difficult to get a supported scenario around session state management using Windows Azure Storage and SQL Azure. Things have changed recently that have changed that around, but we still have caching available as a session state provider and for output caching. So those are part of the SDK. I didn't show this, but you can turn on via config or programmatically the use of local cache. And again, what local cache does is it's not only going to use the cache running the network cache through the Windows Azure App Fabric cache, but it's also going to carve off some of the memory on the machine the app is running and store that data in memory so that when you go to check or get data out of the cache, it's going to first check in memory, which means it doesn't have to go over the wire. The other thing that it means is that if you're using local cache and it's in memory, there's no serialization penalty either. So you don't have to serialize, deserialize the object as you would if you have to put it, send it across the wire to the network cache. There's no size limit for the object. Actually, that's not right. There's no object size limit in Windows Server App Fabric caching, but we do have a object size limit in Windows Azure App Fabric. I'm trying to remember what it is. Let's see if anyone seems to know. I don't remember what it is, but there is a size limit. But what's nice is you can put a managed object into it so long as it's serializable. So this is really nice. It's very flexible in terms of the type of data that you can put in there. This is a big advantage over like Memcache and others as well. You can just put a managed object in there. The APIs that we provide, I think make it pretty easy to plug into applications. And again, it's secured by the access control service. So that's the caching service, and we've got about 5 minutes. I'm not going to go through CDN again since we covered it. This deck doesn't necessarily assume that there's a storage talk beforehand. But suffice to say, CDN is something that you should really consider as part of making your apps secure or scalable. And then there's Traffic Manager. So real quick, we're going to tee up why performance matters in an application. So consider a scenario where you deploy your application to one data center. It works great for the users maybe within 800 miles or so, maybe a little bit further. But as you start getting further and further away, latency increases. And so by the time you're looking at users that are coming across the Atlantic Pacific, that experience gets quite challenging. And so you start looking at different network latencies and all these different characteristics, and the experience can be really, really bad. And so we want to make our applications more responsive to a global audience. We want them to be a lot faster, more interactive, and all these things I think arguably come back to better user experience, more opportunities to capitalize. And so this is where the Traffic Manager comes in. Is it says, hey, deploy your application to multiple places. Deploy it in one data center in North America, deploy it to a data center in Asia, deploy it to a data center in Europe, and we will manage how people get to the right how users get to the application, because we can look at different characteristics provided by DNS and network latency. And so you can even then say deploy it to all 3 data centers. So essentially, by doing that, you get your application closer to your users, and then you let the Traffic Manager be responsible for getting the users there. So let me show you. I'm finding that these examples at least make me feel like it makes it easier to understand. So I'm going to come in here to the virtual network. And it's really hard to, there we go. And under Traffic Manager, and I've got some stuff defined here that I think is kind of interesting. Essentially, what I've done is there's 3 different policies that are available through the Traffic Manager today. And I do want to point out Traffic Manager is CTP right now. It will be going, it will go into production sometime, later this year, early next year, something like that. So sometime in the near future. But basically what you can do is define these policies, and we've got a performance policy, a round-robin policy, and a failover policy. And what the performance policy says is, when I go to a particular URL provided by a Traffic Manager, figure out which instance of the application is closest to me and has the lowest latency. So you can see here that to my performance policy, I've actually attached 3 different hosted services. So I've got the same app, but it's deployed into 3 different data centers. I've got it deployed into East Asia, South Central US, and Western Europe. And so with this policy right here, I also get a DNS name. And so if I open that DNS name, it's routing. I mean, this is cache, right? So DNS gets cached, and it makes it very fast. So most likely right now there was no lookup. But the first time there was a lookup, and based on where I'm at and based on the hosted services that I have added to my Traffic Manager policy, Traffic Manager can figure out which one of those to route me to so that I have the lowest latency possible. And you'll see here that, and this is probably no surprise, that it routed me to my South Central US app. You can see I've also got East Asia. I'll just show you what this looks like. Basically, I've got 3 versions of the app, colored, coded, and updated to look different. And by the way, this is actually, this whole exercise, this demo here, is a hands-on lab in the Windows Azure Platform Training Kit, something that you guys at the hackathon workshop tomorrow can take a look at, give it a try. And so it was able to determine that the South Central application was the one closest to me. There's also round robin. Basically, what that's going to do is you can kind of think of it as load balancing. So it's going to send me, 2 different hosted services based on the policy. So it's just going to kind of load balance across. And it's worth pointing out that I don't have to just add hosted services in different data centers. I can even add hosted services within the same data center. So if I want to establish some sort of a round robin across hosted services within the same data center, I can do so. Traffic Manager doesn't really care where the hosted service runs. It could be in multiple data centers or one data center. And then the last is a failover. And failover just basically says that if one of your hosted services is not available, rather than having someone get a 404 or something like that, instead, direct them to a data center where the application's up. And we're able to determine that by basically having the traffic manager ping your application and get a valid response code. So you can see here it's actually calling out to my application on port 80, and I've got a controller for app health that if the application's healthy, returns an HTTP response code that tells traffic manager, hey, the application is good and healthy. If the app were to crash or the hosted service were to go down, then traffic manager wouldn't get that healthy response code, and it would then send me to a different hosted service that was up and running. So that's the traffic manager. Hopefully that helps a little bit. To wrap this up, because I'm 1 minute over, this is basically what it's there. It's to handle failover, to make it easier for performance. Sometimes you want to be able to easily disable, move things in and out, and so forth. And sometimes hosted services are difficult. This kind of gives you the ability to plug things into a URL that's provided by Traffic Manager. And it also lets you kind of move your traffic around a little bit easier. You can move hosted services in and out of a policy that you've defined within Traffic Manager. And some of the features, the different load balancing capabilities, you've got different TTLs that you can configure, so you can make it, longer TTLs, shorter TTLs, et cetera, and so forth. So essentially, here's what we covered in the talk. We went through securing your app using the access control service, different options for providing connectivity through the service bus as well as Windows Azure Connect, and then ways to scale your app through caching, CDN, and Traffic Manager. So thanks. Question? Go ahead. So the question was, is there any way for the application to provide feedback back to Traffic Manager to tell it about load, like I'm bogged down, hey, can you put some traffic over here and so forth? The answer is no, not today. So actually today we don't expose an API for Traffic Manager that makes it easy to configure. It's something that in the future we probably will. Even at that point, I don't know if that capability is something we've really thought about. I'd be interested in talking to you more about it. But we have other ways of handling load and so forth. Right now we have a diagnostics API that can be used to gather information about the state of the VM and what's going on, and then you can use that to programmatically make decisions about scale out horizontally and so forth. So happy to, if you want to talk offline about that as well. But Traffic Manager doesn't today, and I don't know that it will. So another question. So the question is, where are these metrics that we can use to evaluate how well everything's working? Some of the services provide metrics. So the caching service in particular will raise up even through the portal some information about how much data is in there, how many cache misses there's been, how many cache hits, things like that. We also, so that's specific like to your cache. The access control service, Traffic Manager, the other ones I'd have to think a little bit more about. But one thing we do have, and I don't remember the URL, but you can look it up. Basically, we have a health status page for the entire Windows Azure platform that tells you if we're having any problems with hosted services in a particular subregion or region, how well Service Bus is doing, how well the access control service is doing. You could bing it to find it pretty easily. I don't remember. I don't even know if there's like a short URL for it or not. But we do have a page that you can land on that gives. But that's at a very macro level. It's not at just your app level. Arguably, you'd have to add some stuff of your own to monitor these things. But monitoring has definitely been an area where we've received a lot of feedback that, especially from a developer perspective, we don't provide enough hooks for you guys. Michael Washam, who's on our team, gave a talk at Build on managing and monitoring applications, one of the best that I've seen to date. So if you go to buildwindows.com and look at the sessions, look for Michael Washam, W-A-S-H-A-M, Washam, and he's got a talk managing and monitoring. And boy, he goes ad nauseum through all the capabilities for monitoring apps and ways to do it and using the PowerShell commandlets and so forth. So, all right, I'm over time. If anyone has any other questions, feel free to find me. Other than that, thank you very much.